have any idea like that about how many web pages there are on the web. Scale, search. What percentage of web pages are indexed by search engines? Social interactions and web topology. So these are questions that we can't answer. And these are questions that web science hopes to be able to provide some insight into. Now there are some roots to web science. In 2001, Bernardo Huberman at HP realized that the web had its own ecosystem that could be used as a basis for study. To him, the web was a laboratory, not because of the definition, not because of the pages of the information that it contained, but because of the way it acted, the way it responded to queries. And then you also had people that were interested in web engineering, including some of the efforts here. Where the idea saying is that what we really need to do is think about some sort of systematic mechanism for describing web services, web pages, web sites, etc., because the web was getting too complex. We were far beyond the early days of the web where you saw books such as Teach Yourself HTML in an Afternoon. Nobody could have a full grasp of all of the different disciplines that are important to building a web-based application. Here's an example. Who recognizes this? This, what some people believe, is one now has taken the role of one of the most famous equations in history. Right up there with F equals MA and E equals MC squared. This is the PageRank formula. This is the formula that is worth billions of dollars. The intellectual property of Google. Why is this a root of web science? Well, before Google came along, the search engines that existed, they worked because of the knowledge that computers don't mind doing brute force, boring activities. So just they can scan web pages, pull out keywords, but those words had no knowledge associated with them. They just did it because they could do it fast. But then along comes Google and said, there's got to be something more to that. There's got to be a better way than ranking websites. And in some ways what they turn to is something that's familiar to all the academics that are in here. And that is, academics, when you write papers, you love to be cited by other papers. You know, that's what gets you tenure. That's what gets you recognition. When other people point to your work, and the more people who point to your work, the more important your work must be. And that's exactly what the Google guys figured out. A website is more important when other sites point to it, when its peers judge it as being important. Okay? That is not science, that's sociology. So they took basically a sociological phenomenon and applied it to the ranking of websites. And another interesting thing that has happened is that this formula, where we look at it now, maybe this formula is a fundamental formula of science. Because here, they are using the PageRank formula to determine the extinction between species. It's got nothing to do with the web, but it uses the same mathematical paradigm. So maybe there is something natural happening with respect to that interpretation of ranking pages in Google. One of the things that Huberman pointed out was this idea of scale-free graphs. You know, for anybody who's designed a web page, you know that when you put up a web page, there's no limit to the number of links that you can put. You can put a link anywhere. That's part of the beauty of the web. Well, one would naturally think that given the lack of restriction, that the web would therefore just be a random network, because anybody can put links wherever they want to. But in fact, what Huberman found out is it's not. It follows a power distribution. So there is something happening that really cannot explain that says that what we would ordinarily expect about the relationships in the web is not as random, or is not the way in which we would have perhaps predicted. Okay? And clearly a lot of reason for that is because of the social drivers. You know, because of the ways that we understand that maybe there are the reasons that we add links. We certainly add links for particular reasons, not just arbitrarily, not just randomly. A lot of it depends upon the goals that we have when we develop our applications. And we don't understand what these goals and these motivations might be. So, a case for web science. Certainly, I already mentioned the .com bust. Maybe that happened because we really didn't know how to do commerce on the web. We thought that we could just do commerce like we've done for hundreds and maybe thousands of years, and just pick it up and put it over on the web, and we found that wasn't true. What we didn't expect were people to start using the web for bad things, like phishing. It was not the recognition that part of the social interpretation of the web intended those things that were not so socially good. One question I like to ask is that, you know, Google has approximately 31 billion searches per month. I mean, that's amazing, but how do people ask questions before Google? Right? Right? How do they ask questions before Google? I mean, does that mean that all of a sudden Google brought out all this curiosity in people? Or that people didn't have questions before Google? Right? How did that phenomena work? And I say this about Wikipedia, you know. Why does a concept like Wikipedia just doesn't seem to make a great deal of sense? And the example that I like to use is that my laboratory is right on Sand Hill Road in Menlo Park, which is very close to all the venture capitalists. And I say that suppose I had walked into a venture capitalist office and say, I want you to give me a couple of $1 million because I want to build a dictionary or encyclopedia that users are going to add stuff to. I suspect I would have been shown the door, because it sounds like a stupid idea. You know, especially when you had something like Encyclopedia Britannica, who have the real subject matter experts on all fields. The other thing I'd like to point out here is, suppose 15 years ago I had been able to look into the future and you asked me, what's computing going to be like in 2010? And I said to you, well, computer processors are going to be 1,000 times faster, and we're going to have a new encyclopedia. You would have said, is that the best you can do with computing that's 1,000 times faster? These things, you know, could not have been predicted. They don't necessarily make a lot of sense. Why are people, what is the appeal of Facebook and MySpace? Facebook is now the 3rd largest nation on the planet. Right? That's pretty scary. What does that mean? So how do we deal with ethical issues, legal issues, etc.? Science. How about a web of objects?